everybody, this is Morgan here with Positive Approach to Math. I am rounding out our last lesson of equations using formulas. This one's a little bit trickier, but we're going to get through it. Just a friendly reminder, hopefully if you've been following along, you know the drill by now, that in the details below, there will be a blank PDF of this lesson and the U-Try problems, so you can use it at your convenience. However, that might help you, please feel free. There is also a link to an answer key of the U-Tries, so if you try them on your own and you just want to quick check your work, there's a key there. And if you need a video or a breakdown of the U-Tries, I have that as well in the details, and that will pop up again at the end. Let's round out our last lesson using formulas, right? So a little bit more complex, but the good news is we have a strong foundation of equations, and that's all going to come to play today. It's just going to look a little bit different in that we can't combine like terms because we have different variables in these formulas. This is really helpful for when you get to application problems, and it's just really great to make sure you're challenging yourself. So let's see how we can work through some of this. So we do see more than one variable present sometimes within an equation. And it is sometimes helpful before we utilize that equation in like a word problem or something to isolate the variable that we need isolated first and then substitute the numbers in and evaluate, okay? So we are still going to use the same skills we've been using for solving equations, distributing, combining like terms, simplifying one side, moving variables over to the other side to put them together. And then we're going to use our properties of equality. Oh, we want to get the x by itself? Well, let's get rid of everything on the left that's not x. And so whether that's addition, subtraction, multiplication, or division, that's going to come into play. It's just going to look a little bit different in that you might be combining things that we can't actually combine. Like we might not have like terms, so your right-hand side might look a little bit more intense or detailed, like you might have a 5y plus a 3z because they're not like terms, okay? So nothing we can't handle. So let's just dive right into it and just do your best, and hopefully if you have any questions, we will get those answered today. As you can tell, I'm on lesson 7 and my words are getting all jumbled up. Okay, so let's do our good old draw your line down the equal sign. So we want to solve for W in this problem. It says solve each equation or formula for the variable indicated. So it's saying here's our equation and we want to solve it for W. So I'm going to do a little highlight of W. That's what I want to get by itself. We're going to put the 4W in the box. We know how to move over something that's being subtracted. We know we can add it. And when we move something over, we do the opposite operation. So we're moving it over, so we're going to add 7z, okay? Bring down my 4w. Now it's up to you. You can write 16 plus 7z. What's important to note is we cannot combine them. They are not like terms. I like to write the variable first when I can, so I'm going to write 7z, it's positive, and the 16 is positive, so that will become plus 16, okay? Not terrible, right? So that's why I mean, that's what I mean when I say it looks a little different. That right-hand side, we can't simplify any further, so it does look a little scary. Next, easy peasy. We want to get w by itself. It's currently being multiplied by 4. Let's divide by 4. So we're going to divide this by 4, and what's important, doesn't matter necessarily if you want to do it like this, divide each term by 4, or if you want to write your division or your fraction bar just once like that, okay? Okay, if you go in this direction, I'm going to highlight it, your next step would be to separate it into two fractions. So writing 7z over 4 plus 16 over 4, okay? So if you go ahead and you divide each term by that 4, it kind of saves you from a step, okay? So now I can say, okay, that's going to give me W by itself. 7 over 4 does not simplify, so I'm going to leave it. 7z over 4. You could also write that as 7/4 times z. And then 16 divided by 4 gives me 4. Okay? So that would be my final answer. Now here's the deal. Let me see if I can brainstorm some other ways you might see this answer. So you might see it as 4 plus 7z over 4 in case you wrote the 16 first. And like I said, you might see it as 7/4 times z plus 4 or 4 plus 7/4 times z. So there is more than one correct answer. It's just you're going to have to reach out to your teacher and ask how they want your answer, or maybe they will be accepting of more than one possibility. I know I personally would accept any of these guys. I would not accept this as a final answer. I would want it a little bit more simplified. Okay, so letter B. Draw my line down the equal sign. It's asking us to solve for C, to get C all by itself. So let's see if I can highlight that. Okay, let's put that guy in a box. BC is one term, so we're going to put it in the box. I really think that box method comes in handy here. So we need to get rid of that plus D. What's the opposite of adding D? Subtracting. And because I'm moving it over to the other side, I'm doing the opposite operation. A and D are not like terms. Yes, they're letters, but they're not like terms. They're not the same variable, so we know we can't combine them, so I'm going to write that as A minus D equals B times C. Okay, now hopefully you recognize, oh, B and C are being multiplied. So to get C by itself, all we have to do here is divide by B. And now you're probably like, well, she just told us not to do this. But this would be a case where your final answer, A minus D all over B, I would probably accept that as one fraction because A over B, if I look here, I can't simplify and divide anything there, and I can't simplify and divide anything there. So I like it as the two separate terms when I had something in the first example, 16 over 4, that I could simplify, right? So that's why I wrote it as two separate terms. But because I don't, I would be accepting of really any of these answers. If you left it like this, I would probably accept that unless my directions explicitly said make sure it is written as a single term, right? Because that's two terms. And then I would accept this as an answer. The other thing, if you did A minus D and you wrote negative D plus A and you had that D term first all over B, that would be acceptable as well, but probably I'm hoping you didn't or wouldn't think to do that. Just keep it A minus D. Okay? All right. Last problem. Let's see here if I can slide all the way up to get the rest of what we need in. Okay, so here's a fun one. We want to solve for y. Y, little tiny y, kind of with the x. So I'm going to put that in a box. But as you see, it's one of our beefier fractions there. So it's one term, right? So that entire numerator is being divided by 2. So I'm putting that entire numerator in a box for now because I want to get rid of that division of 2. I want to be able to break up my numerator. So the opposite of dividing by 2, can't forget my line, is to multiply by 2. And remember, I'm multiplying by 2 on both sides. That does not touch anything in my box. It crosses out with the 2 in the denominator. So that's going to leave me xy plus 10. And 2 times z, I'm going to write as 2z. Okay, yep. Even my iPad's getting tired. Acting up. Okay. Now this looks a little similar to the first example we did where, okay, now I got the xy. I'm solving for y, so I put that term in the box. I want to move over my plus 10, so I'm going to subtract 10. xy is going to get brought down. I cannot combine 2z and 10, so I keep them separate. I'm going to write 2z minus 10. It would not be wrong to write negative 10 plus 2z, just probably less common. And then I'm getting y by itself, so I'm going to divide both sides by x. Okay? So that's going to leave me with y equals 2z minus 10 all over x. Now, it would not be wrong to write this as 2 separate terms. 2z over x minus 10 over x. But here, leaving it like this would be an acceptable answer because that division of x doesn't allow me to simplify anything in the numerator. 2z over x will not simplify, and negative 10 over x will not simplify. So I would accept that as one term there. However, this would also be an acceptable answer, but I would be sure to recognize and able to understand in case you were in a multiple choice scenario that those two are equivalent expressions. It would not be wrong if you had negative 10 plus 2z. It would be wrong if you had 10 minus 2z. So you have to watch your signs. That negative has to be with that 10, and the 2z is positive. Okay? So more of a preference of how your teacher would like the final answer, but being able to recognize equivalent expressions is super duper important because sometimes no matter what your teacher says, those standardized tests have something else up their sleeve, right? So you want to be able to recognize a bunch of things are equivalent. So that first example was really great at showing you 4 different equivalent ways to represent W. Okay, summary and helpful hints. Here we are at the home stretch of our equations topic. When you are isolating a variable, you're using a similar approach to solving equations. You put that thing in the box and you strive to get it by itself. You just recognize you can't always combine like terms, so your right-hand side or your left-hand side, whichever side you're moving things to, might get a little bit scary looking, but that's okay. Make sure you are undoing your operations. And, oh, look at my last little reminder. Be mindful about when we can and cannot simplify and combine like terms and distribute and condense our fractions. So we just have to make sure we're very much on the lookout for things and say, look, I can reorganize this, or I can write it like this, or 10 minus 5, I can condense those, but then I still have plus m or whatever it might be. So you just have to make sure you are recognizing and using all those tools from algebraic expressions and from equations to be able to create a simplified expression and to recognize equivalent expressions, okay? So I left you with 6 problems there. Please give them a shot. It's hard to create things that are they're not all going to look identical. Like 2-step equations all started to follow the same pattern, but not in this case because we're dealing with all sorts of different formulas. You're dealing with the volume formula versus the perimeter formula. They look different, right? So we're going to go about isolating our variables a little bit differently, and it depends on what variable they're asking you to isolate. So if you do need help, you know where to find a video breaking down those 6 problems. We are going to be moving on to functions in our next topic, and I'm super excited to get started with that. So great job, everybody, with equations, and keep up the awesome work.